relevant webinar that we have today. So my name is Sachin Ganpati. I am leading the Business Excellence Center of Excellence for the Business Excellence at PMA. Uh, so I will cover 3 points. I would just introduce you very quickly to PMA, the Center for Business Excellence, and also our joint partners, Indian Institute of Industrial Engineering. So I will welcome and no, introduce all. PME is India's premier management association. It was established in 1977 as an independent trust and public organization. It was founded by all-time great industrialists, late Shri S.L. Kirloskar, Mr. V.S. Vaidya, Mr. C.S. Kirloskar, Mr. N.A. Kalyani, and late Mr. C.V. Jog. PME is in the domain of management that empowers and individuals and enterprises to excel in their endeavor. PMA is engaged in research work, creation and distribution of knowledge, enhancement of skills, and application of the best practices. PMA focuses on providing a wide range of services to improve the standards of management practices in India. PMA organizes conferences, seminars, webinars, relevant training programs and lectures, discussions, meetings where experiences are shared, sponsoring specific research projects, forming study groups, etc. PMA has its own library and training hall facility centrally located in Pune. PMA has different centers of excellence, and Center for Business Excellence is one of those. The others are Center of Excellence for Career Guidance, Innovation and Emerging Technologies, Civic Affairs, Skill Development, Quality, HR, and so on. There are 14 such centers at PMA. So if I have to talk about the Center of Excellence for Business Excellence, our mission is to promote sharing and learning of various processes and business excellence methodologies across the industry and academia, provide handholding and support in the application of these methodologies to address specific business and process challenges. And currently we have 3 verticals within our COE: process excellence vertical, project management vertical, and vertical for industry 4. And we may add a few more in future. This is the second webinar that we are organizing in this year 2022. We have recently organized one webinar on project management by none other than Dr. Dhananjay Gokhale, DG. And today is a very interesting topic in the current scenario where we are dealing with huge magnitude of uncertainty everywhere. So that is something I'm sure you're looking forward. I am also introducing our our partners who are associating with us for this particular event. Indian Institute of Industrial Engineering. This was established in 1957 with us in Mumbai. This is a ISO 9001-2015 non-profit organization for propagating the profession of industrial engineering in India. Pune chapter was established in 1970. It has a well-established office at KK Market in Satara Road in Pune. And this is one of the 30 chapters which is very vibrant in India. It provides guidance on non-commercial basis to industries as well as institutes. It conducts productivity case study competition every year, and they have been doing this for the last 20 years. It also organizes one-day training programs on the supply chain management, most lean, etc. They are having a well-equipped library. They organize interactive training programs, and I would take this opportunity to thank Chairman of III Pune chapter, Mr. Mohan Kulkarni, and Mr. Sani, Vice Chairman, for collaborating with us for this particular event in organization. With that, I would finish the introduction, and I'm well on time.
So giving the introduction of PMM and IIIE, that's quite IIIE. I was aware, but it's good to know once again to them. Just to introduce Mr. Yashawant Mahakal. He's our today's speaker, and he will be taking us through the journey of the Lean and Six Sigma way. The name of the topic is Track, Trap, and Treat Uncertainty. As Sachin ji indicated about the industrial uncertainties everywhere for the things which are not under our control, I think this 35-40 minutes journey by Mr. Yashwant Mahakal will definitely be of great help to us. Yeah, just to let some quick things about Mr. Yashwant Mahakal. He has done his BTech in production engineering, and as far as his education is concerned, and subsequently postgraduate diploma in data science. So that's his basic educational qualification, followed by various certifications for multiple global institutes like American Society of Quality, and he is also treated as subject matter expert as lean professional. So that is his certification part. As far as his career, the industrial career goes, he is a founder and principal consultant at Institute of Systems, and this particular institute gets engaged in the field of lean management, Six Sigma, reliability, and project management. And one good thing I must specifically indicate here, that teaching has been his passion. That is one of the very important criteria. And this passion he was able to successfully convert it into practical implementation of these quality techniques industry wide. So that's very important. So whatever he is doing, he has full passion onto it, and does that for the benefit of the industry. As far as his other engagements are concerned, he is on the panel of American Society of Quality India chapter, then CII, then TUV SUD South Asia, and Institute of Quality and Reliability as subject matter expert for Lean Six Sigma and reliability. So that is about his other engagements, which apart from his normal running of the institute, he takes care of that. As far as his professional achievements or the professional completions is concerned or achievements are concerned, till now he has trained almost 500 plus professionals into Lean and Six Sigma green belts as well as Lean and Six Sigma black belts. And he has trained about 1500 plus training man days onto this reliability engineering, which is an extension of all these particular quality techniques. And the most important is, while doing this, he has worked through about 150 plus various organizations in various domains, and have actually practically implemented and completed 1,000 plus projects of Six Sigma and Lean. So that's about him. And while talking to him, while he is speaking, or at the end of the discussion, in case if anybody would like to understand something more on the topic about himself, all are welcome to do that. So I would like to hand over the mic to Mr. Yashwant Mahakal. Welcome to Yashwant Mahakal again, and let us take an opportunity to listen to him carefully. Thanks. Yashwant Mahakal ji.
Good evening, sir.
Good evening.
I'm very happy to be part of this series of seminars, and I thank you, PMA, the COE for Business Excellence, and the dignitaries here, Mr. Mohan Kulkarni, Mr. Sachin, Mr. Ajit, Mr. Pradeep Tupesa, for giving me this opportunity. And a special thanks to my friend, Mr. Sunil Khedkar, who introduced me to this association, and thanks for that. So, trap and treat uncertainty. Our uncertainty is it's something that we were never talking about, but then suddenly we started talking about. But there is a way you can deal with this, and this session will take you through how to deal with that. With all disclaimers, I'm saying this. We are going to cover introduction to the topic basically, and then I'm straightway going to go to the real life case studies, which they are coming from 12. There are 12 different case studies that I wish to speak upon, but then time is a constraint. So let us see to what extent we can we can cover this, and there is a rider to that I should be making it interesting to you and appealing to you. So hopefully I may be able to do that. So friends, let's go with the introduction. You must be aware of these graphs by now. You must be scared of looking at these graphs, and this is nothing but the the COVID graphs that you would be mostly don't wish to look at, daily deaths and daily new cases. And this is the this is the thing because of which this word became unfortunately popular: uncertainty. Otherwise, this uncertainty word for manufacturing people, it was only limited to a guy who is doing calibration in the lab, and he is looking at the uncertainty band for a instrument. And beyond that, I mean, that word uncertainty never came out of the calibration lab as far as manufacturing professionals are concerned. But then the entire world knew about it in last 2 years. So what is this uncertainty? As we all we all experience this. This is the source of uncertainty is something related to, in philosophical language, it is related to unknown and unknowable. Unknown and unknowable. So this is nothing but the definition of truth. This is nothing but the definition of truth, and uncertainty is nothing but truth. We have to live with that. And the truth, by the characteristic of truth, there are two characteristics of truth, that is unknown and unknowable. Fine. So so we're experiencing this reality. Now, how do we deal with this? We need to understand the three categories of uncertainties in business. One comes from the external sources, which is like nature. COVID is one of that. Government policies, society, various cultures, they all bring uncertainty with them. Then in business, the second source of uncertainty is the customer. And if you ask a production planning and control guy, PPC guy, he would always say that the demand fluctuates, schedule fluctuates, and he would talk about that I may get a call by a customer anytime. Okay, and he is the most uncertain person. Marketing guy is most uncertain person. Okay, so it's not that we haven't understood uncertainty ever. In fact, we do that every day, but we never talk about it. We talk about it globally. We started talking about it, so loudly with COVID, but then we were living with this. Then there is organization and supplier network who experiences the uncertainty in purpose, uncertainty in policy, uncertainty in procedures, processes, and the way professionals behave. So everywhere, the uncertainty is seen. And if I may start, there are people who have, there are gurus who have talked about this. Dr. Deming was once asked, what is that one message that you would like to give to the world? And he said, reduce variation. Those were the two words that he said, reduce variation. That means he was talking about uncertainty. And then this is what happened. So from there, the basis of use of statistical tools started in manufacturing industry. It started with Dr. Walter Shewhart, and then Dr. Deming, and then Dr. Juran, and so on and so forth. There are many names that I can take, but then that's how it has reached us. Now, the lean way to look at uncertainty is, you should look at, this is not new to us. House of Toyota production system. We all know this figure. I'm not getting into it. This is the foundation. If you look at this foundation, all the four things, they talk about treatment to the uncertainty. The Toyota philosophy, this comes from this talks about the stability in the purpose or constancy of purpose, which which is one of the Dr. Deming's 14 principles. Then visual management, stable and standardized processes, again talking about uncertainty, and this leveled production. This is the most neglected part, Hezunka, which is nothing but load leveling or smoothing the production load that we give it to the production resources. So these are the 4 foundations, and all of them they talk about taking care of uncertainty. So foundation to the lean manufacturing is nothing but reducing the uncertainty. I'll take you one more slide, wherein lean manufacturing, we are conventionally or we are habitual of only talking about muda, and very seldom we talk about mura, which is nothing but unevenness. And mura happens to be the cause of muda and muri. But then we are so busy in eliminating wastages that we forget about the unevenness, the variation. And all of the including 5S, TPM, you take a tool, it talks about the foundation of that happens to be the reducing variation. We go further. In Six Sigma, what are we doing? We are trying to inherent variation, total variation into inherent variation or variation due to common causes, and the variation in between the resources, which is nothing but the variation due to special causes. Okay, so if I go back, there are ways and means to see. Actually, there is no way to treat uncertainty which comes from the external things. There is absolutely no way. Partially, you can treat some of the things. He being your business partner, your customer, you can tell him, request him. You can't request nature. Customer, you can request and work on something. And then this is in your control. The uncertainties because of organization and the supplier network. So you have to work with your own uncertainties, plus you have to take care of the uncertainties that are coming from customer, plus you have to take care of the uncertainties that are coming from nature. So you have to be 3 times robust. That's what the intention of these Lean Six Sigma tools. So there is a bottom line problem of uncertainty which both these tools talk about, and there are ways to deal with this that are given. I'm not going to get into the various tools. I'm straightway moving towards the first case study, which is talking about one of the foundation of Toyota production system, and that is nothing but Hezunka. This case study is about order execution lead time reduction. This is done with one of our client. This is with our client Specialty Urethanes, who make the nylon wheels which are used for metal handling trolleys. They were victim of the large the uncertainties or longer lead times for their various products, and longer lead times were of this extent, longer lead times to the extent of 44 days, and average of 44 days and median of 54 days, with this uncertainty band of 58 days, which is an interquartile range. So what we did, we applied a tool to understand this variation. We applied a tool to understand variation, which is known as the customer demand analysis, which uses a very useful indicator that is coefficient of variation. Now, this coefficient of variation understands the fluctuations in the demand and average demand, and it's a ratio of mean fluctuations in the demand with respect to the average demand. So what you are trying to understand from this is you are trying to understand how each product has the average lift and what are the fluctuations there. So there is this statistical indicator which is known as coefficient of variation. So based on this coefficient of variation, the products are classified into runner, repeater, and stranger. So lesser COV less than 1.1 is runner, between 1.1 to 1.5 is repeater, from 1.5 to onwards is stranger. So there are these patterns which can be seen for runner, repeater, strangers, and you can identify out of all your products how many are runners, how many are strangers, and how many are repeaters. So there were total 644 products. Now this itself is variety, but this is not variation. You have to serve this. Okay, so you are classifying the products on the basis of coefficient of variation into 3 categories and then giving your treatment. Now the problem with this higher order execution lead times were that they were having a production method which was as per make to order. I mean, whenever customer demands, they would supply. Okay, hence any time when, and mostly since runner parts are are required daily, so they would always focus on doing runners, and then whenever customer demands for repeaters or at times strangers, so somewhere in the in a week couple of times stranger would come, couple of times repeater would come, but all the time you will always find runners are being done and stranger guys or repeater guys are never given priority. Okay, so what we did, we thought of changing this, and we use Hezunka, which is load leveling, which means that Hezunka actually means that every part every day is the philosophy that Toyota tells us. You should produce every part every day in the same amount with repeated patterns. So we thought of applying something like this. So we took an advantage of the manufacturing method that they had. Now this manufacturing method is something very interesting here. What they are doing, they are using, they are having this metal insert here. This metal insert is casted at Belgaum factory, then it is machined at Satara, and then at specialty urethane they are making these nylon wheels. And they have set of three ovens: preheating oven, curing oven, and casting oven, wherein these molds are being used. So these are 21 molds. So, and they make 12 rounds of this 12 rounds of this every day to make the production. So it is 21 into 12 every day. Okay, that's the production quantity. So to take advantage of this, what we did is, instead of putting all runners here on this molding line, we thought of doing something very interesting like this. So instead of doing all runners or all repeaters or all strangers at a time, we thought of taking, actually we divided this into proportion. So out of 21, 2 were every 45 minutes, every round 2 were strangers were put, 6 were the repeaters, and then out of and the rest were the runners. So now, instead of having a stranger being made once in a week, now you are making stranger or repeater every round, that is every hour. And as a result of this, the overall lead times, overall variation in the lead time, that was brought down by almost half, or the mean dropped to, from 44 it dropped to 18.5. The median from 25 days dropped down to 9. The interquartile range, the variation here was brought down from 58 to 17. So that's Hezunka for you, sir. So this is, this simple technique worked, and the production guys got a set pattern, and the variation in the production pattern also got reduced. customers started getting parts early, and finally you could see a picture like this. See, look at the lead times. This is the uncertainty. Customer, because of your problems, customer is facing the uncertainty. Will I get the material or not? Now that uncertainty band has dropped considerably by almost 60%, by almost 60%, and their lead times dropped, and their orders increased, and they are able to treat better. So this box plot shows you the earlier uncertainty. This is the box plot band, and this is the band that they are having now. So previously the outliers were not so high, but now because of the reduced variation, outliers would start from here, which were now earlier these were not treated as outliers statistically. Only these were treated as outliers more than 150 days. Now, even if it is more than 1.5 months, then it is treated as outlier. So that's what happened because of Heizunka. Heizunka is a way to deal with, it's like reducing variation in the way the production batches are taken, having a repeated pattern in the production shop floor. This is the most neglected tool. We will talk about 5S, TPM, SMD, Kanban, but we will never talk about Heizunka because it is difficult to implement. Fine, so that is the first case study, friends. Let us go to one more victim of uncertainty, that is, variation in the cycle time. Industrial engineers by nature, they are, they will always find out the averages. They will never take into account, though ILO, the Industrial Engineering Handbook says you should find out the standard deviation, but it is not practiced. It is not practiced, and they will only find out the averages. So what happens here is, this is one of our client, Pro5 Engineering from Chakan. They have a line setup wherein the some assemblies for apparel parts, apparel store parts of Apple. They make these parts. They make this stainless steel parts, and they buff them to have the mirror finish. So this is the process wherein buffing happens. This is the pre-welding buffing, and then welding happens, and then there are 10 stations where the buffing, final buffing happens to make the mirror finish. Now the problem here were that the buffing content is so high that, and it depends on a lot of inspections. So though there is a line, single piece flow, so-called single piece flow, but there are small batches, 5 to 10, small batch size 5 to 10, still they were having problems. Now the problem was because of, and we were all clueless, why are we having lesser output? So we started, we started tracking the cycle times for each part, and we did almost for 20 odd parts at different times. And then what we realized is that the cycle times, and we used box plot and ANOVA, analysis of variance, as a tool for understanding the variation in the cycle time. We were all using this averages, but then there is variation in the averages. So there is within group variation, within station variation, and between station variation, which is causing the trouble. And along with this is uncertainty. So what we did, we tracked it basically. We tracked it. We measured the cycle times. We did time study, and we realized that these are not. This is to be dealt separately. So we found out the takt time for this, and the takt time was around 100.8 seconds, and then the output was 150 numbers per shift, and we found out the deviation of the means from the takt time. Okay, so these were the deviations from that, and wherever the deviations were more and the variations were more, those were found out, and those were the operations where you can see this highlighted red portions here. These were the operations where the deviation from takt time was more. So this was identified. So for these stations, the industrial engineering process mapping of operation, transportation, storage, delay, inspection, all activities were bifurcated into this, and we found out for each operation what are the contents for the value adding and non-value adding. Okay, so this was this after doing this, we worked on we worked on reducing transportation, storage, delay, and inspection. Inspection content was higher. If you just look at this, inspection content was higher as much as the VA content. So we wanted to reduce on that. So it is because of the poor buffing wheel that we had. So we changed the buffing wheels, and we did other 25 kaizens for reducing transportation and storage. And finally, what happened, because of that, the cycle times came down, and their variation also reduced. And the analysis of variance, which was used for comparing the variances, showed that now the variation is not significant. And that's how we got rid of the cycle time variations in the cycle time. I mean, not rid of completely, but then to the extent that we were able to supply to the customer with the required schedule. So we reduced on the mean cycle time and reduced on the variation of, so that we are the entire variation, barring few exceptions, all are lesser than the takt time. The entire spread is lesser than the takt time. So we could manage to raise the production from 150 to 266. Okay, so that's the second case study. Let's move on to the third one. This is transportation cost reduction. Now, transportation is again is dealt with by PPC, marketing, stores, logistics people, and there is a network of drivers and the fleet owners, who would the guys from the godown and the logistic guys, the third-party logistics. So all of them are there. So it becomes a complicated affair if you have more number of vehicles. We had a client which was having 6 vehicles, and they were all 4-wheelers there, and they were getting material from 396 suppliers, supplying it to 13 customers. And there were 7 drivers. 7th driver is on the bike, so I have not included it here. Variety of goods they were handling was 24,000, and number of routes that they were dealing with is 1890. Now, and their transportation cost per month was 122, so 1.22 lakhs per month. So this is a group wherein they are using their own vehicles, and we were given task to reduce this transportation cost. So we started tracking it. We thought that manual tracking would help, and we started with there were some mechanism available to track the rupees and kilometers, etc. We started getting into kilometers, but the number of trips were so huge that it became difficult for us to track. So we adopted GPS tracking of vehicles. We fitted in each vehicle GPS trackers were given, mobile apps were given that, and so for tracking uncertainty, you need to invest with all automated gadgets. So that's one of the example. So distance traveled by vehicle, idle time, routes traveled, stops taken by vehicle, help tracking movements of vehicle in real time, like that. So now what we did, we performed combinations of from to locations, then found out total number of routes. Then for each route, we found out what is the frequency of uh, frequency of vehicles, number of vehicles making trips on given route. So and then uh, we have also found out the cost. So based on certain calculations, we found out, uh, we categorize the routes into high cost and high frequency. So the frequency of vehicles varies, and the cost also varies, and the complexity is also very high. So it becomes a difficult problem to tackle. So we divided the routes into high cost, high frequency, high cost, low frequency, low cost, high frequency, low cost, low frequency, and then we thought of giving treatments to that. So this is the historical data that was collected from the gadget. Now what we did, we again did some analysis and found out the routes which are high cost, high frequency. So for all 4 routes and their contribution for each of the vehicle. For each of the vehicle, all 6 vehicles were, they were given this. They were analyzed which vehicle for which route and all. So the critical routes for the vehicle were found out. Now what we did, we had an approach to deal with high cost and high frequency route first. So 5 destinations, including this one customer. Vehicle runs on this route on daily basis. So one big four-wheeler vehicle is identified for addressing all the high frequency, high cost routes. Then long distance routes were given to one more vehicle, which is high cost because of long distance, and low frequency routes. So there was one vehicle which was given for this route. Earlier, all vehicles were used to do the work of every route, and it was all disrupted. So we tried that. So for high cost, high frequency, we gave one vehicle on which will work on daily basis. Another vehicle which will for high cost, low frequency, which will work on weekly basis. Then for low cost, high frequency, one vehicle covering multiple routes on daily basis. So he's the guy, he will go to every, he is the guy who will face the most uncertainty. And low cost, low frequency, one vehicle covering multiple routes on need basis as and when required. So that's how the classification was there. So it was tracked so well through GPS. It was trapped with the logic of high cost, low cost, high frequency, low frequency, and it was treated with these prescriptions. Okay, and after that, now there is again Hezunka here for deliveries. So weekly, this is like the weekly. If you go to any mess, they will have big mess. They will have weekly schedule of breakfast, lunch, dinner, and they will keep repeating it in the same manner without any change. So we thought of that idea and did weekly plan for all the 4 vehicles. Down to not drastically. 30,000 mein kya hota hai? But then still it is the effort, effort put by all of us, and which gave us this relief of almost a year for getting these 2 vehicles released itself is a big thing. Okay, getting a so this is one case study. Third case study, the transportation cost case study. I'm deliberately keeping quality case studies away because if you talk about Six Sigma, they're always all the time they will all the time talk about quality related. But then I wanted to like to take your attention to this. This is short blasting, steel short consumption reduction. Now these are this is the case study which is related to short blasting process. There are steel shots being used. Now these also are very they are getting consumed since they are steel shot. Their cost is higher, and there is wastage in that, and that needs to be reduced. So what we understood, first of all, we for the short blasting batch, the load in the short blasting machine was never measured. So we put a load sensor there, and we measured the weight of every hanger that would go into the short blasting machine, and we got this. This is uncertainty. This is uncertainty. You can see an almost uniform distribution there. You will see multimodal distribution there, and it occupies the range. Weight per hanger is almost ranging from 0 to 1000. So or it ranges from 40 to 950. So this is uncertainty. This range is very high, and they were saying that 300 is the logic. 300 should be the lower limit. It should not go below 300. So we put an automated lock there, and now you can see a sorted histogram. There is nothing on this side. 300 portion is gone. So we could see the result, but then we became greedy. We put further lock of 400 kg, and then I was further greedy and saying that no, now you make it 500. But then that greed was not helpful, and I had to take banking, and their delivery is delayed because of they had to wait for 500 kg load to come. So we again switched back to 400 kg, and then there was some reduction that we achieved. Then we worked on there was also variation on how many parts are being loaded. So there were some parts which were loaded with a lower number of parts per hanger. So we improved the fixturing, and we improved the numbers per hanger. And then there were some other kaizens that were made. And finally there were some cycle time reductions that were done. And we finally, from 1.64 kg per ton, which is very high, and because the number of tons that you produce on those short blasting machines is very high, and this is reduced by almost 25%. Okay, so that's it, friends. Thank you so much. Hope I tried to do justice to the topic. I'm not sure, but thanks for listening. And
taking us through various different type of cases, which probably gave all the attendees a very good idea what exactly. So that's great, great methodology of getting into details of because if I understand correctly, whatever I have learned of Six Sigma and Lean, it's not a very cakewalk type of a topic, but so Yashawant Mahakal, you made it reasonably simple, not getting into a lot of mathematics and a lot of this thing. The basic thing of this is a lot of data point collection, analyzing that, using various methodologies, tools, technologies, and automation, get into some kind of reports and take a weighted management decision, which increases the productivity and reduces the cost. So that's overall the understanding of this. Now, I would like to
first.
Kishan, Sunil Khedkar.
Yes, sir.
Right.
What was the last action actually? Remedial action was taken, corrective action for last case study, short blasting. I missed that. The action taken.
See, action taken was the providing the load sensor itself, so that you don't go below 400 kg per hanger. That is the most you are not productive when you put the lesser castings there. So that is the most, and those loads were available. I mean, but yeah, they are not put because of urgency. So you are planning in such a way that you are giving the sufficient load to the shot blasting machine. So that is the first part. I mean, and that itself, it's not only the load sensor, providing load sensor and the automation. It's also the planning that helped. Planning that was done. From knockout, how the load will come, and you will fill it up, because 300 kg is not.
So as far as
It was
the
utilizing the hanger capacity basically, and increasing the hanger capacity instead of working on the steel shot
Right.
cost. Yeah.
Okay, but as far as the cost is concerned, because I'm sure when there is a recirculation mechanism in the shot blasting machines to use the same shots, and maybe
Yes.
one of the reasons for the high shot consumption could be the disintegration or problem with the breakage of the shots because of
Even
the
if you do that,
shot
sir,
blasting parameters.
even if you do that, see, we all verified that, and that those wastages are not that great. We have done that. The main problem that I have not gone through the entire 300 slides presentation. It's only few slides that have worked most. So what worked most in this case was, increasing the output, increasing the hanger capacity in the same shots, same amount of shots. You are putting more load there, and reducing the variation in the amount of load that you are providing for.
In the production load leveling, how did you manage the setup times? Because you started producing all the variety every day, right?
Yes.
So
The
how did you,
setup time
the
is
economic batch quantity kind of thing?
We did that by increasing the number of molds.
Okay.
Yeah, molds were made available. I mean, there was no setup time as such. You have to just make the mold. It's a casting, polyurethane that is being poured. So you have to just place the wheel on the conveyor. That's it. So making that wheel, the mold available for that particular casting is important. So we increase the number of molds to arrive at this. There was no setup time related issues, but we increased the number of patterns.
And the metal composition or the charge was the same for all the variety?
Yeah, there were hardly 3 varieties.
Chemistry.
Chemistry was three things. So that is also not a big problem. The setup time was hardly 5 to 10.
You have explained in excellent way all 3 case studies, how to reduce the variation, uncertainty. Yeah, it will be Lean SigmaWay. You explained in excellent way. So on behalf of IIII Pune chapter, we convey our sincere thanks and congratulations to you. Yeah.
Thank you so much. Thank you so
Yeah.
much.
Yeah.
Thank you. Execution. We cannot go the same way like we are going for mass manufacturing or automotive scenario or manufacturing scenario.
Absolutely.
Here, for project management, you need to make use of tools like CPM, PERT, or the guidelines that are given by Theory of Constraints by Dr. Eliyahu Goldratt,
Right.
which talks about the critical chain project management, use of fever chart, use of resource buffers, and the feeding buffers. So buffer penetrations. So all these tools needs to be used. The crashing of critical path, those needs to be used. And again, in that, for crashing, you go for reducing the value adding and non-value adding things.
Yeah.
And fever chart for tracking, if you ask me, for tracking, fever chart is the best tool for tracking multiple projects at a time, wherein you compare the how much percentage of task is completed in how much percentage of time that is given by the customer. So never go the same way as the lean manufacturing usually talks about. So there are different set of tools which one should be using for project management.
Okay. Yeah.
That's
Understood.
one. That's one.
Yeah.
Now, second is service. I believe, rather I'm firm believer of whatever you are doing, you do any business or any activity for that matter, not even business.
Yeah.
If you are measuring something, you can always
Improve.
always improve. Means before improve, I'll say you can collect data, you can analyze data,
Yeah.
understand, explore. So those things are possible. And if
Yeah.
you are not doing any measurement, logical and relevant and timely measurements,
Yeah.
that too in computer, not
Yeah.
on hard.
Yeah. Yeah. Yeah.
If you are doing it in computer, that is must. So
Yeah.
then only you would be able to analyze something.
Yeah.
So service industry, whether it is design or training institute like a school, college, or retail malls, etc. Everybody, they are having more data. So any service industry can, for that matter, work on productivity, work on quality. There are error rates which are reduced. So people are implementing lots of things with great enthusiasm.
Yeah.
So, but only thing is that you should have this measurement things in place.
Yeah.
Now, answering third part is, unfortunately, the almost the management is not profit focused.
Okay.
We have been, I might be biased when I'm saying this, but then we have been, through quality management system or customer satisfaction pressure, we have been always talking about quality and quantity. Quality first, quantity secondary, and then nobody talks about cost. There is no system available except some CA tells him every quarter or every year to look at the profit. So are we looking at the profit every day? If an owner or the top management are looking at the profits every day, I'm saying every day, like we are dealing with customer complaints every day, deliveries every day, we should be talking about profits every day.
Absolutely.
And if we do that, if we have that mechanism to track profit every day, I think rest of the things will be taken care.
Yeah. Got it.
Yeah. So I hope I have answered you, sir.
Yeah, thanks a lot. Thanks a lot, Mr. Yashawant Mahakal. I think in a very short time you were able to give me a very crisp answer. So sincere thanks for that.
Let's hand it over to Nitin for vote of thanks.
Yeah.
Yeah. Well, Yashawant Mahakal ji, rather you touched upon to all the areas where one need to understand the complexities of